Alright, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So today we are going to continue our class in chapter 2. So today will be the last class of chapter 2 lah. Okay, we have covered so far two subtopics in chapter 2. Chapter 2 is basically a small chapter lah, as compared to chapter 1, which is quite a big chapter. We took about 4 or 5 weeks to finish chapter 1, but chapter 2 is a bit small. It only contains of 3 subtopics. So now we are going into the last subtopics of chapter 2, which is the equation of motion, and we are going to use cylindrical components. Okay, so basically when you hear equation of motion ni, you kena tahulah it is F equals to ma. Equation of motion means the Newton's second law of motion. Okay, so let's look at the lesson outcomes for today's class. So at the end of this class, you should be able to revise your memory about the cylindrical coordinate. We have learned about cylindrical coordinate in chapter 1. So nanti saya akan tunjukkan, I will show you what the cylindrical coordinate is all about, just to refresh our memory. And then we are going to formulate the equation of motion F equals to ma yang kita belajar sebelum ni. We are going to implement the equation of motion in cylindrical component ataupun dalam cylindrical coordinate lah. And then finally we are going to solve a few questions related to the particle kinetics using cylindrical components. Okay. So again, I would like to repeat this slide. Whenever we would like to apply the equation of motion, we need to have our initial reference frame. So inilah yang menjadikan 3 subtopik dalam chapter 2 ini. Chapter 2 ini we have subtopik menggunakan rectangular component, XY axis. And then in the last class, we talk about normal and tangential component, okay, NT axis. And for today's class, we are going to implement cylindrical component. So basically, the subtopic in chapter 2 is based on the coordinate system that we use to define ataupun to write our equation of motion. Okay. So previously when we talk about curvilinear motion, okay, rectangular coordinate is where you define a coordinate system in a fixed position, and then we have the position of the object, position of the particle, which can be written as as a vector in IJK component. If it is a 3-dimensional problem, then dia akan ada K component lah, component of Z axis. Tapi dalam case of 2-dimensional problem, dia akan ada I and J component sahaja. So for example, R, the position of this particle can be 6I plus 8J meter. Ini kita panggil sebagai rectangular coordinate. So the coordinate system is fixed on the earth. Okay. Ini rectangular coordinate. Dan daripada rectangular coordinate ini, we have implemented the equation of motion. Okay, equation of motion untuk rectangular coordinate, kita dapat fx equal to max, fy equals to may, dan kalau 3-dimensional, kita akan ada satu lagi axis, iaitu fz equals to maz. So basically dia sama sahaja dengan inilah. So rectangular coordinate system menggunakan xy axis. So we have our equation of motion for rectangular coordinate in xy axis lah. So this is used for rectilinear motion. So apabila kita ada problems related to curvilinear motion, then most of the time we will use normal and tangential coordinate. Normal and tangential coordinate ini dia berubah-ubah mengikut position of the particle. So let's say we apply our normal and tangential coordinate at this point. So tangential axis will be tangent to the path here. Normal axis will be 90 degrees pointing towards the center of the arc. Dan apabila partikel ini bergerak, the axis will also move together with the object, with the particle. So tangential axis at this moment now becomes tangent to this path, and then 90 degrees to the tangential axis is the normal axis pointing to the center of the arc. And then apabila dia bergerak lagi, the axis, the tangential axis will change as well as the normal axis. So for normal and tangential coordinate system is fixed on the particle. So as the particle move, the anti-coordinate will move as well. Okay, this is just to refresh our memory about rectangular coordinate system just now, and then now we are talking about normal and tangential coordinate, and then we have then implement the equation of motion in terms of normal and tangential coordinate. And if the problem is a three-dimensional problem, then you're going to have one more axis which is called binormal axis. So basically we have tangential axis, normal axis, and binormal axis. So binormal axis ni, there is no motion in binormal axis. I have explained in the previous class. So AB, the acceleration in binormal axis will be equal to 0. So total force in binormal axis will be equal to 0. And then we have Ft and Fn equals to Mat and Man. And from the first chapter, we have defined that At is equal to V dot. So we can rewrite the equation like this. And An is equal to V square over rho. So the equation can be rewritten as in this form. So this is normal and tangential coordinate. So now we come to the coordinate system that we would like to cover today. That is the cylindrical component. So it is still using xy like the rectangular coordinate. And now we have our position of the object from the origin O. So we draw a line R ini, like this. And then if we continue in this line, along the position vector, we will call this as radial axis. Okay, this will be our radial axis. Ini saya sedang menunjukkan macam mana untuk define the cylindrical coordinate. Okay, so cylindrical coordinate ni basically daripada xy coordinate sebelum ni, kita define, or we take the position of the particle, of the object from origin O, and then the same line we use to define the radial axis, and then 90 degrees to the radial axis. Before that we have our horizontal reference line taken from the x-axis, and then from the horizontal reference line we can have the angle theta from horizontal to the position vector, to the radial axis ni. Position vector R ini dia ialah the same line as the radial axis. So this will be our angle theta. And then 90 degrees to the radial axis, we have the theta axis, ataupun kita panggil sebagai transverse axis, menggunakan simbol theta. So the cylindrical coordinate ini menggunakan R for radial axis and theta for transverse axis. Okay. So in chapter number 2, we are going to apply the equation of motion in cylindrical coordinate. F equals to ma. Remember, equation of motion is the Newton's second law of motion. F equals to ma. So since we are talking about cylindrical coordinate, then we will define the equation of motion in terms of this axis lah. So we have r axis tadi, r axis here, which is the radial axis. So it will be equal to mar. And then we have kita punya theta axis ataupun transverse axis. f theta is equal to ma theta. And then if it is a three-dimensional problem, z-axis is the same as the rectangular coordinate. It is defined as fz also. So fz equals to maz. But this is a very rare case because most of the time we will only focus on two-dimensional problem, which is fr and f theta. And from previous lesson, we have also defined what is AR and what is A theta. Okay, AR is R double dot minus R times theta dot square. Dot here means d over dt. I have explained many times. Whenever you see a dot symbol, it means that it is d over dt. For example, here, if theta dot, it means d theta over dt. If r double dot, which means that it is a double differentiation, d over d square r over dt square, ataupun d over dt of r dot, which means that it is the velocity lah. R is the position, r dot is the velocity, and then you differentiate again, r double dot is the acceleration. For A theta is equal to R times theta double dot. Also the same, theta double dot means d over dt of theta dot plus 2r dot plus theta dot. Okay. So theta here means the angular motion of the object. So if you refer here, if you imagine an object is rotating about point O, so you can imagine that theta here is changing over time. So the faster the object is rotating about O, then theta will become larger. So this shows the angular velocity of the object. Okay. So that is all about the theory of this. So basically AR is called the, sorry, ini ada salah sikit. AR is the radial acceleration. Later I will correct this. AR is the radial acceleration. A theta is the transverse acceleration. So basically the acceleration component, the acceleration has two components lah. When it comes to cylindrical coordinate ni, acceleration ada two components. Okay. Do you have any question before we go to some examples for you to see the topic clearly? I think we should do some problem lah. We should solve some problem, and then you will see how you can use this equation to solve the related problems. Ada apa-apa soalan before I go to the example? Boleh saya pergi ke example?
Boleh, sir.
Okay, alright. Okay, so let's look at example problem 1. Okay, you can see the picture here. The smooth 0.5 kg double collar can freely slide on arm AB and the circular guide rod. Maksud dia AB ni ada satu arm. Arm ni macam satu batang ataupun satu rod lah. So C ni ialah collar. Collar ni dia boleh bergerak di sepanjang bulatan ni. So if you imagine the motion of this thing, dia bergerak lah, dia berpusing macam tu. Okay, if the arm rotates with a constant angular velocity, dekat sini you boleh tahu, when you are facing this kind of problem, you have to use cylindrical coordinate. Kenapa? Because it has theta dot dekat sini. Theta dot ni menunjukkan angular velocity. Dalam subtopik yang lain kita tak ada angular velocity ni. So maksud dia AB ni rotate at an angular velocity. Maksud dia beza angular velocity dengan velocity yang biasa ialah velocity yang biasa is the change of position. So let's say point A is over here moving to B with at certain time, and then you have the velocity of the moving object in straight line. Tapi sekarang ni dia bukan bergerak dalam straight line tapi dia rotating. So in a rotating motion, we always refer as angular velocity. So berapa change of angle with respect to time. Okay, so maybe it starts with 0 degrees like this, flat, horizontal, and then it starts to rotate, and then you will see the angle theta becomes larger and larger with respect to time. As time increase, the angle pun increase. So dia akan jadi angular velocity lah. So angular velocity is written in radian per second, bukan degree per second. So this is the SI unit untuk angular velocity. Okay, so if the arm rotates with a constant angular velocity, 3 rad per second, determine the force the arm exerts on the collar at the instant theta equals to 45 degrees. Motion is in horizontal plane. Okay, last week kita ada, in the last class kita ada problem saying that motion in vertical plane. So beza dia is, when it says vertical plane, then we have to consider the weight, the mass mg, weight mg. Tapi bila dia kata motion in vertical plane, you imagine this thing kita tengah tengok daripada atas, daripada top view. So which means that the weight is acting downwards into the surface. So kita tak payah weight tak akan ada di dalam free body diagram kita, because we are now considering only 2-dimensional problem. Weight tu bertindak dalam aksis yang satu lagi, aksis yang ke dalam, ke dalam apa, pointing downwards lah, kalau you imagine kita pandang benda ni dari atas. Okay, so soalan dia ialah berapa force yang arm AB ni yang rotate, arm AB ni beri kepada collar dekat C ni yang bergerak. So berapa force yang diberi, force the arm exerts on the collar at the instant theta ni equals to 45 degrees. Okay, so we need to draw the free body diagram first lah. So how many forces yang ada bertindak kepada collar C? Sekarang ni we are focusing on collar C. Apa force yang ada? Apa force yang ada? Tak tahu. Okay, yang pertama sekali ialah collar C ni dia in contact with the surface of this thing lah, in contact with the surface of circular guide rod ni. Dia ada circular punya shape ni. So bila dia ada contact, I have mentioned earlier also dalam previous class, whenever there is contact akan ada normal force. Okay, so ada normal force di sini, kita assume normal force ni bertindak ke bawah. Okay, normal force ni bertindak straight ke bawah sebab sekarang ni dia berada pada top position. Dan akan ada force, yang force ni kita nak tahu, akan ada force daripada rod AB ni bertindak kepada collar at C ni. So these are only forces yang ada bertindak pada collar at C. Weight tak ada sebab weight bertindak ke dalam, tadi saya beritahu dia bertindak ke dalam aksis yang satu lagi. Okay, so if you look at this figure, yang mana kita punya radial axis, yang mana kita punya transverse axis. This is important. We need to be able to define axis kita tu di mana. Siapa boleh bantu saya? Which one is the radial axis? Dekat mana? Anyone? Tak ada? Tak tahu ke apa? Dengar ke tak ni?
Tak tahu sir.
Tak tahu, tapi dengar suara saya kan?
Dengar.
Okay, so kalau kita tengok slide kita yang tadi, okay, yang ni kita akan ada satu origin. Dari origin kita define kita punya position of the object. Lepas tu dari position line yang sama ni ialah radial axis. Okay, now we go back to the problem just now. Okay, so origin kita kat mana sekarang ni? Origin kita is at point A. Point A ni tak bergerak. It's a fixed point. So point A ni origin kita. So kita punya position of color C ni ialah this line lah. A to C. This is the position of color C. Therefore, kita punya radial axis kita ialah selari dengan ni lah, pada line yang sama. Pada line yang sama daripada A ke C, this will be our radial axis. Okay, so ada diberi angle theta dekat sini, so the same angle theta is up here lah. Okay, and then kita ada satu lagi, transverse axis is 90 degrees to R. So dia akan follow motion lah. Motion sekarang ni tengah nak bergerak ke atas. So we gonna have our transverse axis ni point ke atas 90 degrees daripada R. Okay, so with now we have defined our radial axis as well as our transverse axis. Okay. So next step ialah to apply the equation of motion lah. So nampak kita dah define our radial axis ni positif ke atas sini. So kita tulis arrow ke atas positif. Okay. Force in radial axis equal to MAR. Okay, apa force yang kita ada dalam radial axis? Cuba tengok pada radial axis. Force F ni ada tak komponen dalam radial axis? Ada tak? Tak ada kan? Force F ni, yes, force F ni is acting on the transverse axis. So force F tak ada komponen. The only force yang ada komponen dalam radial axis is the normal force. NC ni is the normal force. So we have theta kat sini. So we can then separate this force into components. So dia akan jadi NC cos 45 degrees. Kenapa 45 degrees? Because dalam soalan ni diberitahu theta equals to 45 degrees. So NC cos 45 degrees, which will be pointing downwards in the opposite direction as R ini. That's why dia jadi negative. Dan itu sahaja. Kita tak ada dah force lain. So equal to MAR. Itu satu equation of motion. AR kita tak tahu, NC pun kita tak tahu. So kita tak boleh solve apa-apa lagi from this. Now we go to the second equation of motion. So now we write the equation of motion in transverse axis. Okay, transverse axis kita nampak positif ke atas macam ni. So total F theta in transverse axis equal to MA theta. Okay, force yang kita ada dalam ni ialah the force F ni positif, because it is pointing up, and then we can have the component of NC also pointing downwards. So dia jadi negative NC sin 45. Okay, equal to MA theta. Okay. Dan daripada tadi kita dah tahu AR is equal to R double dot minus R times theta dot square. A theta is equal to R times theta double dot plus 2R dot times theta dot. So sekarang ni kita kena dapatkan all the components ataupun all the parameters atau variable dalam equation ini, so that we can calculate what is AR and what is A theta in order for us to find what is NC and what is the force F. Okay. Given in the question, R is equal to 0.8 cos theta. Okay. So now what we need to do is to find R dot. Sebab dalam equation ni ada R dot. So what is R dot? R dot ni tadi saya bagi tahu apa? Kalau ada dot tu meaning dia apa?
Acceleration.
Sorry?
Acceleration.
No, not necessarily acceleration. Dot here means d over dt. So R dot means d over dt of R. So R sekarang kita dah ada d over dt of 0.8 cos theta. So when we differentiate d over dt of 0.8 cos theta, what do we have? Boleh tak kita differentiate ni? can we differentiate d over dt of cos theta? Ini dia balik kepada yang dulu kita dah ada tunjuk sekali, chain rule. Kenapa kita kena guna chain rule? Because differentiation kita over dt. But our variable in the function ni, theta, is not t, is not time, but it is theta. So we have to use chain rule to solve this. Macam mana nak guna chain rule? We have to do a little bit of manipulation. So dia akan jadi d over d theta of 0.8 cos theta multiply with d theta over dt. So sebenarnya ni kalau kita mansuhkan d theta dengan d theta, dia akan dapat balik equation yang sini. Do you see it? Boleh nampak tak? Boleh nampak tak? Kalau kita mansuhkan d theta di sini dengan d theta di sini, kita akan dapat balik equation yang sebelumnya, d over dt. dt will come here. Okay, so this is chain rule, how you solve this using chain rule. Okay, when we have this, kita boleh differentiate macam biasalah. Now we have d over d theta, 0.8 cos theta akan jadi minus 0.8 sin theta. Differentiate cos akan dapat negative sin. So minus 0.8 sin theta. Yang belakang ni, d theta over dt is theta dot lah. So this will be our r dot. R dot ialah equal to minus 0.8 sin theta times theta dot. Okay, settle satu. Dalam equation ni juga ada r double dot. So we need to differentiate this one more time. Okay, we need to differentiate this. R dot tadi yang kita dah dapat ni one more time. So r double dot is equal to d over dt of r dot. d over dt of r dot. Okay, this is what it means by r double dot. So we will differentiate whatever r dot is lah. So to make the differentiation easier, kita bring minus 0.8 ni kat depan, because this doesn't have anything to do with the differentiation. So sekarang you ada d over dt of sin theta times theta dot. Ni lagi complicated. Macam mana kita nak differentiate this? Okay, ini pula kita panggil sebagai product rule. Okay, dia ada satu lagi rule dalam differentiation, nama dia product rule. Kita differentiate dua benda yang multiplied with each other, sin theta and theta dot. So to do this, you will assign satu sebagai u, satu sebagai v. So sin theta is u, theta dot is v. Okay. Now what you do is, we have to find what is u prime. U prime ni ataupun u dot lah, dot pun boleh, prime pun boleh, is equal to d over dt of u. Okay, so d over dt of u. U apa sekarang ni? U is sin theta. So what we want is d over dt of sin theta. So kita kena pakai balik chain rule tadi, sebab d over dt sin theta tak boleh solve, because here is theta, our differentiation is over time. So we have to do the manipulation again. D over d theta of sin theta multiply with d theta over dt. Okay, and then ini boleh solve lah. D over d theta of sin theta dapat cos theta. So dapat cos theta. D theta dt ni ialah theta dot. So you dapat u prime is cos theta times theta dot. Okay, now we go to the v pula. Okay, ini kita dah dapat tadi. Sekarang kita pergi ke v. V prime ialah d over dt of theta dot. Theta dot ni is already d theta over dt. So if you differentiate over time sekali lagi, dia akan jadi theta double dot lah. Dia akan jadi theta double dot. So we have u prime is cos theta dot, cos theta times theta dot. V prime is theta double dot. Okay, so to solve this using product rule is, to solve this, you kena buat u prime times v plus u times v prime. This is how product rule works. Minus 0.8 ni kita bawa tepi dulu. Kita fokus yang dalam bracket ni sahaja dulu. Okay. So, U prime tadi kita dah dapat. Saya tulis kat sini. U prime is cos theta times theta dot. Tadi daripada kita punya differentiation tadi. Multiply with V. Apa V kita kat sini? V kita ialah theta dot juga. So, multiply dengan theta dot satu lagi. And then, settle. Now, plus U. U is sin theta. U yang biasa. U yang tak differentiate. Multiply with V prime. V prime tadi kita dah dapat is theta double dot. So, you multiply with theta double dot satu lagi. And therefore, we have our R double dot. So, this will be the equation ataupun the function of R double dot. And then, dalam equation ni juga, kita perlukan theta dot and theta double dot. So, theta dot is given. Angular velocity theta dot is 3 rad per second. Okay, 3 rad per second, constant velocity. So, what will be the angular acceleration? Kalau velocity constant, angular acceleration dia ialah 0 lah. Angular acceleration ni is theta double dot. So, theta double dot will be 0. Kenapa? Because the angular velocity is given as constant. Okay. Kalau ada question, you terus tanya. I will move on. So, daripada tadi, we have all the R tadi yang daripada kita punya calculation before. We have R, we have R dot, we have R double dot. So, now kita akan calculate for theta equals to 45 degrees. Sebab dia bagi tahu sini, at the instant 45 degrees tu kita nak tahu berapa force dia. So, R at 45 degrees is 0.8 cos 45, dapat ini. And R dot is, kita gantikanlah. R dot tadi belakang ni kita dah dapat minus 0.8 sin theta times theta dot. So, minus 0.8 sin 45 times theta dot ialah yang given ni lah 3 rad. So, times 3. You dapat minus 1.669 meter per second. R double dot, kita dah dapat tadi minus 0.8 cos theta times theta dot times theta dot. So basically this will be theta dot square lah, plus sin theta times theta double dot. So you gantikan semua. Theta double dot ni 0, theta dot is 3. So theta dot square tadi 3 square, and we will get minus 5.091 meter per second square. Okay, so therefore bila kita dah ada semua value ni, kita boleh ganti dalam this equation. AR is R double dot. So, kita ambil value R double dot minus 5.091 ni. Minus R yang atas ni. And then theta dot square is 3 square. So, kita dapat minus 10.18 meter per second. A theta, acceleration, transverse acceleration, is R times theta double dot. So, theta double dot 0. So, this side becomes 0. Plus 2 darab R dot is this one, minus 1.69. Theta dot is 3. So, in the end dapat sama value dia. Minus 10.18 meter per second juga. Okay. Tapi ni kita belum selesai lagi. We will then bring back the equation of motion untuk kita gantikan AR ni dalam this equation of motion. Then we will get what is the value of normal force. Okay. So, normal force kita akan dapat 7.2 Newton. And then, when we have 7.2 Newton normal force, we will substitute in this equation to get the force actually equals to 0. There is no force acting on this. At this moment, force acting on the collar C is 0. Okay. Do you have any question for this example problem? Ada soalan?
No question.
No question?
Yup, sir.
Yeah.
Actually, how to get the NC and F
How to get NC and F?
in the FBD?
In the free body diagram?
Yes.
Okay.
The earlier one, NC and F in the FBD.
Okay, because the collar at C is in contact with this circular apa ni panggil, circular guide rod ni. Dia ada circular guide rod ni, mungkin dia dalam bentuk yang cylindrical punya shape, so dia circular macam tu. So this thing must be in contact with the circular guide, so there will be a normal force lah. Whenever there are contact between two objects ataupun contact with an object with ground, there will be normal force. So ada normal force satu acting on this, acting on the collar. And then juga collar ni ditolak oleh rod AB ni, rod AB yang berpusing menolak collar ni untuk bergerak. So there must be also a pushing force lah dekat sini. So this is how we got these two forces acting on the collar C. Okay. Boleh saya teruskan sikit lagi?
So A is static, right?
A is static, yes. Point A is not moving.
Oh, so the force is acting on B, B, so the C can move.
The force is acting on point C lah. On point C. Yeah.
Okay.
Okay. Alright. Okay. Let's look at one more problem. Okay. If you look at this problem, ini pun lebih kurang sama. So if you imagine this arm here, AO ni dia move, dia rotate. Okay. The arm AO rotates. Okay. And then when we draw the free body diagram, okay, the object, the particle here, the ball is in contact with the arm. So akan ada satu the arm is pushing the ball here, the particle. So there will be pushing force lah. So the force applied by the arm is downwards like this. And then the ball ni dia is in contact with this thing lah, with the groove apa, I'm not sure what this thing is called. Maybe it is a groove where the ball is travelling in the groove. So akan ada satu normal force. Okay, dia in normal force ni mesti sentiasa straight dengan okay, ada soalan kejap. It says constant angular velocity, not constant velocity. So acceleration is not zero. The one that is zero is the angular acceleration, not the normal acceleration. Okay, you have to differentiate between angular velocity and the linear velocity. We don't normally write linear velocity, but when we write velocity, it means linear velocity. Otherwise, we write it as angular velocity. Okay, the one that is constant here is the angular velocity, theta dot, angular velocity. So that's why theta double dot is zero. But A is linear acceleration. Linear acceleration is not zero because linear velocity is not zero. Okay, it's not constant. Sorry, it's not constant. Okay, so let's continue with this. We have a force pushing the ball. We have the normal force at the contact point between the ball and the groove here. And then from here, we will define our radial. Nampak ni from O. O is the fixed point. This is R, the position. And then we continue with the radial axis kat sini lah. I zoom in sikit. Okay, this is the radial axis. And then 90 degrees to the radial axis will be the transverse axis in this direction. Okay, now the problem is what will be the angle here of the normal force? What will be the angle? Because when we would like to calculate normal force nanti, kita kena tahu what is the angle of this normal force ni. Angle dia from normal force to the radial axis ini. So what we can do is we can draw a tangent line to the path. Okay, saya zoom in sikit. At this moment, the particle is moving along this blue path. Blue ni dia punya path perjalanan dia. So at this moment, we can draw a tangent line to the path. Okay, and then tangent line ni will be 90 degrees to the normal force tadi. Tangent line will be 90 degrees to the normal force. Okay, so what we can have from here is we can get an angle daripada radial axis ni ke tangent line tadi, ke tangent line ni dipanggil sebagai psi. Ini simbol, a Greek symbol, a Greek alphabet known as psi. So psi ni, okay, ni this is another representation of the same thing. With the R is known, the function of R is known. R ni dia punya path, nampak? R is given as 0.1 theta. That is a function of R. With a known function of R, we can calculate the angle psi ni using this formula. Tangent psi is equal to R ni, this thing, divided by dr over d theta. Okay, differentiate of this thing. Okay, so this is what I want to show in the second example, the same figure. Okay, let's read the question. First, a can C having a mass of 0.5 kg. So, ini sebenarnya pandangan dari atas. Nampak top view. A can. Can ni macam tin, Coke, whatever brand. So imagine that this is in the factory producing the can, the soda lah. So this arm here is pushing the can to the next station. Move along a groove horizontal slot. The slot is in the form of a spiral. Okay, the slot is in the form of spiral, which is defined by equation R equals to 0.1 theta. Okay, the spiral here ni equation dia, function dia, where theta is in radian. If the arm OA rotates with constant rate, again, don't get confused. Constant rate theta here means constant angular velocity, not constant linear velocity. Linear velocity is not constant. The one that is constant is the angular velocity. So constant rate theta dot is equal to 4 rad per second in the horizontal plane. Okay, when you see in the horizontal plane, meaning that we know this is from top view. So weight dia bertindak, weight is acting down. Weight is acting down inside, in another axis. So we don't have to consider weight dalam kita punya calculation. So what we want to do is determine the force it exerts on the can. So determine the force yang arm yang berpusing tolak can ni, berapa force yang dia beri pada can at the instant theta equals to pi rad. Okay, theta equals to pi rad. Neglect friction and size of the can. Okay, so let's draw the free body diagram. It's almost 4. I'm gonna go a bit fast. Nanti kalau you tak faham, you boleh tanya, ataupun you can, I will upload this video and you can view back in YouTube lah. Okay, the free body diagram, we have the force by the arm here pushing the can. So the force here FC lah saya panggil, sebab this is point C, the can, FC. And then like I mentioned earlier, we also have the normal force at contact point between the can and the groove. Okay, then we draw a tangent line to find the angle psi here. So what is but what we are interested in is not the angle psi, tapi the angle ini phi ni. Ini panggil nama dia phi. Yang ni nama dia psi. Okay, psi plus phi ni akan jadi 90 degrees lah kalau you nampak, because tadi saya dah tunjuk the angle between tangent and normal force ni 90 degrees. So we can determine the angle psi from this R here, and what we are really interested in is this angle phi kat sini. Okay, so given R is equal to 0.1 theta, dr over dt is 0.1 lah. dr over d theta is 0.1. Theta ni hilang lah, differentiate. So tadi kita dah ada equation kita, tangent psi is equal to R over dr d theta. So kita dapatlah 0.1 theta over 0.1. So kita boleh potong 0.1 and 0.1. Tinggallah tangent psi is equal to theta. Theta here given as pi rad. So at theta equals to pi rad, psi, the angle psi is then arctangent of pi. So you can use your calculator to calculate what is the arctangent of pi to get psi equals to 72.34 degrees. Okay, tapi remember saya bagi tahu what we are interested in is this angle here, phi. So phi is then 90 degrees minus minus the angle psi here, 72.34. So kita dapatlah phi is equal to 17.66 degrees. Ini angle yang small ni. Ini yang kita nak because later we will need this angle to calculate the component of NC. Okay. Now, let's continue. Kenapa kita perlu angle tu? Because tadi pun saya dah tunjukkan we define our coordinate system like this. Okay, ni R punya line and then kita continue dia sebagai radial axis here. And then 90 degrees to the radial axis is our transverse axis. Transverse axis, theta punya axis lah. So we need the angle psi ni untuk dapatkan component of NC in radial as well as in transverse axis. Okay, so now we write in our equation of motion, Fr equals to MAR. Kalau you tengok dalam radial axis, we only have the component of NC. So NC positive pointing in the same direction as positive R. NC cos phi, NC cos phi is equal to MAR. Okay, NC kita tak tahu, AR pun kita tak tahu. So we cannot solve it yet. And then we go to the transverse axis. F theta is equal to MA theta. The force yang kita ada in transverse axis is the positive FC. And then we have negative NC punya component. NC sin theta negative. Okay, sin phi. NC sin phi negative is equal to MA theta. Okay, so we have our formula daripada yang sebelum ni. AR ni is R double dot minus R times theta dot square and A theta is this formula. So then we need to find what is the value of each and every one of these items lah supaya kita boleh calculate what is AR and what is A theta. So given in the question, theta dot is 4 rad, constant. Therefore, we know theta double dot 0. Ini yang 0. 0 is the angular acceleration, not the linear acceleration. Given also, R is 0.1 theta. So, what will be R dot? What will be R dot? R dot sama macam tadilah, dr over dt of 0.1 theta. So, now we have theta and t. We need to use chain rule balik lah. D over dt of 0.1 theta. So we need to use d over d theta, 0.1 theta times d theta over dt. So this will be 0.1. This will be theta dot. So in the end we have R dot is 0.1 theta dot. Okay. And then the last one, which is 0.4 meter per second. Kita substitute terus. Theta dot ni kita ada kat sini 4. So 4 times 0.1, we have 0.4 meter per second. Okay, we have all this. And what's left is the R double dot. So R double dot is basically d over dt of R dot. Tadi kita dah tahu R dot is 0.4 meter per second. So d over dt of 0.4 is 0 lah. So we know R double dot is equal to 0. Okay, so at theta equals to pi rad, we have AR, kita substitute all the values. R double dot is 0 minus R is 0.1 times theta here kita ganti dengan pi lah, 0.1 pi. Theta dot is 4 square. So kita dapat minus 5.027, okay, for AR. A theta kita gantikan juga dalam equation ini. So we get in the end 3.2 untuk A theta. Okay. So then we can solve lah the equation yang daripada sini. We have NC cos phi is equal to MAR. So NC sama dengan MAR bahagi dengan cos phi lah. Phi here is the angle yang kita dapat di atas ni. So kita dapat minus 2.638 Newton. Okay, that is NC. And the force kita substitute dalam second equation. Force ni NC sin phi ni bawa ke kanan. MA theta plus NC sin phi, we have 0.7997 Newton untuk FC. Okay, so that solves our problem lah. Okay, sorry for having to do this very fast because we don't have much time. So do you have any question? Ada apa-apa soalan? Okay, kalau tak ada soalan, you can go back and watch this video again, and I will also give you the slides. If you have any question, you can always write in the WhatsApp group ataupun you boleh private message saya lah. I will try my best to answer. Okay, so again, to summarize what we have done today, we have formulated the equation of motion using cylindrical component. Tadi F equals to MAR and F theta is equal to MA theta. And then we have also tried to solve particle kinetics problem using cylindrical components. Okay, so with that we have finished our second chapter of dynamics. And we need to do a quiz for this second chapter, and also the test. Next week is mid-semester break, so I think we will do the quiz and test after the mid-semester break. Is that okay with you?
Yes, sir.
Okay, later nanti saya akan update bila tarikh untuk test dan bila tarikh untuk quiz. So probably after mid-semester break, hari Isnin kita akan buat quiz. Quiz yang kedua. And then itu hari Isnin. Hari Rabu kita akan buat test. Test tu akan ambil masa 2 jam semasa kelas lah. Okay. So later more detail about the test I will explain later lah. Alright. So if there is no more question, then thank you for coming to the class. This will be the end of our chapter 2, and after the mid-semester break, after the test, we will start with chapter 3. Okay? Ada apa-apa soalan lagi? Okay, so kalau tak ada soalan, Okay, alright. So kalau tak ada soalan, thank you. And I will see you again after the mid-semester break. Okay, Assalamualaikum and have a good day.